All right, class, in this video, we continue our discussion, section 6.3 in your note packet on Riemann sums. And so we're going to pick it up in this video at the top of page 82. And we're working another example where we're estimating the area under a curve and above the x-axis between two values of x, using rectangles to estimate that area. And so at top page 82, you're instructed to compute the right endpoint Riemann sum for f of x using 4 equal subintervals over the interval from -2 to 2. So again, this closed interval from -2 to 2 refers to the values of x. So we're talking about from x equals -2 to x equals +2. Now, you're asked to use 4 equal subintervals. That means we're going to have 4 rectangles. So x equals 4, and we're doing this from x equals -2 to 2. So a is equal to -2 and b is equal to +2. So the width of each rectangle, delta x, right, is equal to b minus a over n, which is equal to 2 minus -2 over 4 in this case, which is equal to 1. So each rectangle has a width of 1 unit. And so we're starting at x equals -2, and so over here on the x-axis, the base of the first rectangle goes from -1, or from -2 to -1. The next one from -1 to 0. Next one from 0 to 1, and then the last one from 1 to 2. So those form our 4 subintervals over here, right? From -2 to -1, -1 to 0, 0 to 1, and 1 to 2. Now, we got for each rectangle, we got to find the value of x that we use to determine the height of each rectangle. Well, up here we're instructed to do a right endpoint Riemann sum. So for a right endpoint Riemann sum, we pick the right number in each of the 4 subintervals. So in this first one, right, we use -1 for x. The second one 0 for x, the third one 1 for x, and the fourth one 2 for x. So now we got to find the value of f of -1, f of 0, f of 1, and f of 2. Well, we're not given the algebraic expression for the function f of x. We're just given its graph, and its graph here is in green. So to find value of f of -1, we go to x equals -1 on the x-axis, and then we find the y-coordinate on the graph at x equals -1, and you'll see the y-coordinate for that point on the graph at x equals -1 is 5, so f of -1 is equal to 5. At x equals 0, right, the point on the graph is up here, and the y-coordinate is 6, so f of 0 is equal to 6. At x equals 1, this is the point on the graph at x equals 1, and the y-coordinate is 5, so f of 1 is equal to 5. And then at x equals 2, this is the point on the graph at x equals 2, and the y-coordinate is also +2, so f of 2 is equal to 2. So now we know the 4 function values, right, for each for the corresponding 4 values of x, and so these are the heights of the rectangles, 5, 6, 5, and 2. So to calculate the total area, right, so you see I've drawn the 4 rectangles. To calculate the total area of those 4 rectangles, right, we can, you take the height times the width, but the width is the same, so you can just, for each of the 4 rectangles, so you can just add up the 4 function values up here, and then multiply that sum by delta x. And so the sum of the 4 function values is 5 plus 6 plus 5 plus 2, which is equal to 18, and 18 times 1 is 18. So the total area of our 4 rectangles up here is 18 square units. Now you notice we can't say whether we underestimated or overestimated the area under the curve and above the x-axis from x equals -2 to 2, because some of the rectangles contain the graph of the function and some of the rectangles do not. So we can't say whether we're overestimating or underestimating. But we do know if we use more rectangles, if we use 8 instead of 4, right, and cut the width in half to 1/2, we would get a better estimate for the area under the curve. All right, and so down at the bottom, page 82, it asks you, how do we find the most accurate area under the curve? And I just sort of alluded to that answer, right? We increase the number of rectangles. We make the number of rectangles n very large. And so remember, this is the formula, the Riemann sum formula at the top of page 1, right? We're just adding up n rectangles. F of xi is the height, delta x is the width, so that product is the area of a rectangle, and we're just adding up the area of n rectangles. So if we increase this n, the number of rectangles, we get a better, more accurate estimate of the area under the curve. Ideally, we increase the number of rectangles without bound. If we take the limit as n goes to infinity, right, increase the number of rectangles without bound, then the Riemann sum will equal the area under the curve and above the x-axis exactly.